With the rise in popularity of devices like Amazon's Alexa, we're beginning to see an ever-present device with the sole purpose of assisting the user in their day-to-day life. With devices like this, the ability to blend seamlessly to the background becomes an important non-functional requirement, also known as invisibility. Hi, I'm Rani Rogan, and today we will be covering how developers believe invisibility impacts NFRs related to user interaction. In this presentation, I will include what invisibility is, how it is cataloged, the findings of this research, and the possibilities for future work. So what exactly is invisibility? Here is the formal definition of invisibility. It is invisibility in UbiComp and IoT applications refers to either a merging of technologies in the user's physical environment or an interaction workload decrease, both aiming to provide a greater focus of the user on his everyday tasks. So what exactly does this mean? UbiComp refers to ubiquitous computing that is present in everyday life. IoT stands for the Internet of Things, which is the collection of smart devices that are present in our day-to-day lives, a key part of UbiComp. In essence, invisibility is the ability for smart devices to blend into the user's environment in order to not distract from the user's tasks. So why is this important? With UbiComp, there's a new set of NFRs, or non-functional requirements, that it brings, namely HCI, which stands for Human-Computer Interaction. HCI focuses on the ways that users interact with technology in order to create more intuitive and useful interfaces, which allows for the user to interact with the computer in more novel ways. NFRs may have interactions between each other known as correlations and can either help or hurt. In this research document, we are specifically looking at the correlations of invisibility with user interactions. Our current knowledge of invisibility's correlations are quite limited. We do know that invisibility is an essential characteristic for achieving UbiComp. Only 3 catalogs contain invisibility as a subcharacteristic of ubiquity, which all trace back to just one study. With UbiComp becoming more prevalent, it's important to understand how to design these systems in a way that can manage multiple NFRs, and that means selecting strategies based off of known correlations to achieve them. Invisibility contains several soft goals, which is a collection of concepts and strategies related to the NFR and how to achieve it. Several soft goals have already been recorded for invisibility. There are quite a few soft goals listed here. They're broken down into specific strategies such as facial recognition, which is used to help identify the user and unlock the device with minimal user effort. These will be used in order to find the correlation between invisibility and other NFRs. So the main challenge here is figuring out a procedure in order to catalog invisibility. To do so, the research was split into 5 steps: planning, collecting, analyzing, validating, and reporting the data. In the first phase, the interview script was written in 4 parts: an introduction, instructions, demographic data, and questions about the interview itself. Then 44 soft goals were linked to the question, what is the impact of this soft goal on user interaction quality? User interaction quality was defined as 5 characteristics to impact the quality and use of the final user as a combination of the quality and use and product quality model as defined by the ISO/IEC standard. These characteristics were then split up into 40 sub-characteristics. First, developers were asked to indicate the overall impact of the soft goals on the scale of break, hurt, help, and make. They were also asked if they had any other feedback, such as opinions on whether each aspect of the NFR could be impacted. Finally, they were asked to give their reason for the positive or negative correlation. In total, there were 472 answers to the interview question. Most developers thought that make and break impacts were too extreme, so researchers decided to define the correlations as help and hurt only. Deductive content analysis was performed on these answers. Content analysis is a method for classifying text data through identifying patterns. The deductive approach uses preconceived concepts to create codes, categories, and themes. In this case, we know that we want to analyze NFRs related to user interaction quality. Therefore, we can categorize by the type of correlation, the type of quality model, characteristics, then sub-characteristics. This graphic shows the predefined concepts used for codification of correlations. On the left are all the helpful correlations, while on the right are all the negative correlations. A few NFRs that were not previously defined were mentioned several times by developers and therefore added to the list. There were a couple of conflicts where both positive and negative correlations were reported for the same NFR. In these cases, the correlation with the most citations was selected. Overall, 120 correlation rules were created. Several of the methodology steps were validated in order to ensure the data was correct. Firstly, the interview went through 2 rounds of evaluation. First through 2 professors and an HCI researcher to discover ambiguities and problems, then through a pilot interview, which was conducted with a developer that works with IoT applications. Secondly, developers were required to have at least 2 years of experience in fields related to UbiComp and IoT to participate in the study. Only developers who were familiar with the specific soft goals were asked the questions related to the impact of that soft goal. Next, 7 experts were asked to validate their findings. Each expert was required to have a PhD and work in the area of the soft goal that they were validating. They were asked to state whether they agreed, partially agreed, or disagreed with each rule. Rules that were disagreed with were thrown out. Those that were partially agreed with were analyzed to include conditions so that they were more accurate. The catalog of findings is as follows. From this graphic, you can see each NFR and the amount of positive and negative correlations it has for each of its subgoals. As you can see, most NFRs have both positive and negative correlations. Specifically, performance efficiency, functional suitability, and satisfaction have several similar levels of positive and negative correlations. This is where a correlations catalog is useful, as you can select specific strategies that can benefit both NFRs. These next few slides contain the correlations created by the study. In the first column is the correlation ID, followed by the strategy of achieving invisibility. The NFR that it's linked with is in the right column, and between the two is the impact, shown as a green plus sign or a red negative sign for helpful or hurtful. So for example, if I'm considering using Google Home, I can see that it has a positive correlation with accessibility, but a negative correlation with security. I can use this information to prioritize which NFRs I want to achieve or change my design plans to account for multiple NFRs. So these are all the NFRs with positive correlations and are ordered by the most positive first. Usability has the most positive correlations at 22, with its sub-characteristics of accessibility and appropriateness recognizability having the most positive occurrences. Researchers found that natural interfaces and minimizing user effort helped usability. Just looking at the NFRs with the most positive correlations, it does make sense the system that is focused on invisibility will have a high usability and performance. Minimizing user effort with both the usability and blending the system into the background and a faster performance will seem more natural to the user. These NFRs all have negative correlations and are ordered by the most negative first. Security had the most negative correlations at 10, mainly related to alternatives to authentication. Some of the sign-in APIs can adversely affect confidentiality, and facial recognition can be easily spoofed, affecting authenticity. Security had no positive correlations related to soft goals. A more secure system would be noticeable and obtrusive to the user, so there has to be a balance between security and visibility based off of the system that you're designing. So in conclusion, our key correlations are related to usability and security. Usability had the most positive correlations, while security had the most negative. While an invisible system is much more intuitive to use, security can be harmed by many of the strategies that invisibility employs. However, most NFRs had mixed results. They had both positive and negative correlations based off of their different subcharacteristics. Though most NFRs lean towards either positive or negative, a couple had the same intensity for both. When NFRs have mixed results like these, it's important to select a strategy for achieving visibility that will help rather than hurt. So correlations catalog can help developers find these strategies with positive correlations. So how can we improve this research? Researchers hope to increase the usage of this catalog by software engineers, especially among those with little experience with UbiComp and IoT systems. The catalog can be expanded by taking more developer and users' feedback into account. For example, devices like Amazon's Echo can be studied to see how users interact with it and how they would assess its invisibility. From a developer standpoint, the strategies implemented in these devices can be examined to see how successful they are. Furthermore, this research can be improved by investigating the relationship and visibility with other NFRs. The scope of this research was limited to the quality of user interaction. However, there are other NFRs related to UbiComp and IoT systems that can be explored, such as mobility. In conclusion, invisibility is becoming much more prevalent as an NFR thanks to the rise in UbiComp devices such as Amazon Echo. It's important to understand how invisibility impacts other NFRs in order to select strategies that best allow for achieving multiple NFRs. Thank you.